Good day everyone, and welcome back to our YouTube sessions. And today we are going to talk about esterification. So we need to understand what exactly is it that is called esterification, what kind of organic reaction is it. So before we can get deeper into the topic of esterification, let's also talk to those people who are just joining us today. If it's the first time to watch our videos, make sure that on your way out you also press the subscription button, you also press like and notification button, so that the more we send the videos, the more you'll be notified of other content that we'll be sending. So okay, let's get into the content of the day. Like I said, I want us to discuss or to see what exactly is esterification, how does esterification take place. So understanding from this, let us get to know what is esterification. It's a process. So it's a process in which esters are formed. It's a process in which esters are formed. So what are esters? Most of you understand esters. These are organic molecules. But how are these esters formed? So these esters are a result of a process, like I said here, of a process in which carboxylic acids, they react with alcohols. So it's a process again in which carboxylic acids, they react with alcohols. So we have kind of a model here in this case whereby for us to make an ester, we need alcohols. Alcohols, they are added to carboxylic acids, and then we get an ester. So this is kind of like an equation in which we are saying that alcohols must be added to carboxylic acids for us to get what are called esters. Alright, so let us go deeper into understanding using some structural formulas, so that at least we see how exactly an ester is formed. But before we can get deeper into that, let us also understand that this reaction involves a catalyst. In this case, the catalyst that is going to be used, it is sulfuric acid, which is H2SO4. So sulfuric acid in this case is the catalyst which is used during the process. And we also need heat. So let us understand some dynamics whereby why do we need more sulfuric acid as catalyst? Why do we need more heat in order to have this reaction to take place? So as a point to note, I want you to understand also that this reaction cannot take place without the catalyst. Reason why this reaction cannot take place without the catalyst is because of intermolecular forces that are found in alcohols. Alcohols, they have an OH group. Carboxylic acids have a COOH group. So therefore, this reaction to take place, it needs a lot of heat. It also needs sulfuric acid to make sure that we break down the stronger intermolecular forces, which are the hydrogen bond forces that are found in both of these molecules. So therefore, this reaction requires a catalyst, which is sulfuric acid and heat. So now we have the model that alcohols need to react with carboxylic acids to get esters. Let us see now, having an example of some structural formulas to see how then do we come up with an ester and what is going to be the functional group of esters. So, like I said, we have our model. Our model is such that alcohols, they react with carboxylic acids and we get esters, but the process takes place under H2SO4 and heat as catalyst here. Alright, let's get this. The alcohol that we want to use, let's have this alcohol here. So if we have, if we're going to have ethanol here is an alcohol, is a primary alcohol. Ethanol reacting with the carboxylic acid, let us have propanoic acid. So propanoic acid has a structure which looks like this. This is propanoic acid. So we have propanoic acid. Propanoic acid is going to react with an alcohol. So what we now need to see is how then do we make an ester? And our ester will look like what? So we don't forget H2SO4 and heat as our catalyst. So during the process, during the breaking down of both of these molecules to make an ester, what we are going to see here is that the alcohol is going to provide the OH, and then the carboxylic acid is going to provide one atom of hydrogen here, which means when you remove OH, when you have a hydrogen, both of them together, they will give you a byproduct, which is water. So we're saying from this process, water is a byproduct which is formed. We will have H2O as the byproduct formed out of this process. So once we remove the OH, and once we remove again one hydrogen atom from this carboxylic acid, which is the end atom here, we are left with this cation and this anion here. They are going to combine together to make our major product, which is the ester. Let us make the ester. So the ester, we are taking the remainder of this, which is going to be 1, 2. The remainder of this alcohol has 2 carbons and we have 5 hydrogen atoms surrounding. So we are going to collect that. Then after collecting this one, we are going to join to this cation which is left from the carboxylic acid when we removed one hydrogen atom to make H2O with this. So therefore what we are trying to say is that this is now joined to this. How is it going to be joined? It is joined from the end. This is the end. So this is the end here. We removed one hydrogen. This is the end which is left. So this bond comes here. This bond comes here. Then we have an oxygen. Then we have another bond. Then we have carbon with an oxygen atom here in this way. Then we have 2 other carbon atoms like this in this fashion here. So this is how we make an ester. So an ester is now formed. This is esterification. But now let's give this one a name. That's another thing which is very important. How do we give names to esters when they are formed? So when we give names to esters, we need to be very careful. Our alcohol was ethanol. This was our alcohol. Our carboxylic acid was propanoic acid. This was propanoic acid. This was our carboxylic acid. So to name this ester, we need to count number of carbon atoms from the alcohol. The alcohol, ethanol, provided 2 atoms. So therefore, that forms the prefix of the name of the ester. So 2 atoms of carbon, that becomes an ethyl. 2 carbons and ethyl. Then we come to the carboxylic acid. The propanoic acid provided 3 carbon atoms. So therefore, this will form the suffix of the name of the ester. So we have 3 carbon atoms here, which means this forms the root name, which is the suffix. So the root name is according to the number of this, which is going to be propanoate. In this case, we add then propanoate. This is the name of the ester that we make, which is ethyl propanoate. It is formed out of the reaction between ethanol and propanoic acid. So this is the structural formula, and the byproduct that we have is a water molecule. This is the water molecule which is formed. So in conclusion, what are we trying to say? Esterification, alcohols react with carboxylic acids. But just to put this in the right way also sometimes, because when you discover that some other textbooks, they may not give you a structure which looks exactly like this. They may start with a structure with 3 carbons and then this one. Let us see what kind of a structure will that be. So in this case, another structure which is the same as this one is that we can still have esterification whereby OH and an H, they join to form H2O. But our structure can start with this from the carboxylic acid, which is going to be 1, 2, 3. So we have this from the carboxylic acid exactly as it is, because one hydrogen atom is gone, so we are left only until the oxygen atom here, which means from here we join with this. OH is no longer there, it's gone, to form the water molecule. So we join with this here, we join with this. So in case maybe you go through some other textbooks when you're studying, you'll find that they write ethyl propanoate. We still name it in a standard way as to taking note of how many carbon atoms came from the alcohol. That convention, according to the IPAC naming, does not change. 2 carbon atoms from the alcohol, they are here. They are found on the other side, which the connection where there's carbons with an oxygen, that's your carbons from the alcohol. So they are still 2, which is, it is still ethyl. We still have 3 here. This is propanoate. So we still have the same name, but the structures, they look kind of different. Why they are different, the reason is because the cation from the alcohol is now on the end. The cation from the alcohol is at the beginning, but is the very same way of naming them. So this was esterification. Thank you so much for watching our videos. We see you in other videos. Thank you.